Welcome back. Okay, so what we have now is we've got a question that's asking us for the minimum distance from a point Q to the plane. Here's your diagram. So, they have Q up off the plane. To be honest with you, you better check that. Because if Q lies on the plane, what's the minimum distance between the point and the plane? 0. And I've been known to do that. So let's take this. Let's put 1 in for x. Let's put 3 in for z. Let's put negative 2 in for z. So it'll be 4 minus 3 is 1, plus 2 is 3, plus 6 is 9. 9 equals 0. Did it satisfy the equation? That's a big no. That means my assumption that that will satisfy the equation is wrong, which means that that point does not lie on the plane. This diagram is, in fact, good to go. Okay, so actually what they're asking here, if you think back to projection method, is they're asking for the projection of that, which we will call PQ, or QP, okay, where P naught is any point on the plane. So they're asking for the projection of that onto that, which is the normal. It's not as bad as you think. Let's write it out. What they're actually asking for is the projection of QP onto the normal, which you should know the formula. QP dot N over magnitude of N. And that's going to be a distance, so this has to have a positive value. Okay, so there's actually absolute value bars around this, not magnitude bars. So just remember that, okay? So we're not going to want to get a negative answer here because we're talking about a distance, the projection. Some people will actually put the absolute value bars, but I think that tends to make people confused and they start thinking that they're magnitude bars and they're not. Okay, so let's talk about PQ. We need a point. We need any point called P on the plane. However, will we do that? Well, guess what? Any values of x, y, and z that make, that proper word here is satisfy, that make equals 0 is a point on the plane. Let that thing sink in for a minute. This is the equation of a plane. Therefore, anything at all that works, that satisfies this, is a point on the plane. So I'm going to make up one. I'm going to put in 0 for x, I'm going to put in 6 for y, and I'm going to put in 0 for z. That seemed pretty easy. What do you think? What do you think about 0, 6, 0? I think it's pretty good. That'll give me 0, subtract 6, subtract 0, plus 6 is 0. So this point lies on the plane. So I'm going to let that be P. There's a lot of other ones. I'm going to use that one. All right, now I need the normal. Need the normal of what? I need the normal of the plane. Well, how are you going to do that? I'm going to use the equation of the plane. The normal is A, B, C from AX plus BY plus CZ plus D equals 0. So your normal is going to be equal to 4, negative 1, negative 1. Let's go back to the formula. Can you see that? Yeah, you can see that. So let's do QP. QP is going to equal OP minus OQ, which in this case is going to be, what did I choose for P? 0, 6, 0. And what was given to me as Q? 1, 3, negative 2. So that'll be negative 1, 3, 2. And so now using formula, Hello. We're videoing right now, so come on in and join us, but quietly, please. So what we have here is -1, 3, 2, dot. The normal, which is 0, 6, 0. Hey, I'm not on the page. Where are you people? You got to tell me. And then it's going to be over top of the magnitude of 0, 6, 0. So the dot product is going to be 0 plus 18 plus 0. That was hard. The bottom is going to be 0 squared plus 36 squared plus 0 squared square rooted. So that's 6. Have I done everything right? That seems like an awfully nice round number. Sometimes things work out. Go figure. All right, I'm going to pause there. If I've made a mistake, fix it. Let me know in the group chat, but I think I'm good to go. And we got one more after this.